So here we have problem number 38 from chapter 2 in our textbook, the Night Book, and it reads, ball bearings can be made by letting spherical drops of molten metal fall inside a tall tower called a shot tower and solidify as they fall. A, if a bearing needs 4 seconds to solidify enough for impact, how high must the tower be? And B, what is the bearing's impact velocity? So you can see here I wrote down the information that the time that it falls is 4 seconds and it starts from 0 meters per second. So if we want to find the height that the tower must be, we're just going to go with our second kinematic equation for part A of y is equal to y sub o plus v sub oy t plus 1/2 g t squared. Okay. If we take the top of the tower where the ball is falling from to be the initial height, then y sub o is 0. It starts from rest, so v sub oy is 0. And then we're just left with 1/2 -10 and 4 squared. So solving for y, we find that the tower needs to be 80 meters up in the air. Part B then asks, what is the speed when it hits the water? All right, so we know that all falling things accelerate at -10 meters per second squared. So that means every second that the object is falling, it's going 10 meters per second faster. So using that information, we can just find out that if it falls for 4 seconds, it's going to be going -40 meters per second when it hits the water, or again, 40 meters per second in the downward direction. The math that proves that is just using the equation v sub f equals v sub o plus gt, where again it starts from rest. Gravity is -10, and we've got 4, so v sub f will be -40 meters per second. There you go. There is problem number 38 in chapter 2.